Thanks, Anita. Sounds pretty cool. You know, NASA is working on another propulsion technology. It's called Vasimir. Dr. Franklin Chang Diaz can tell us more about that technology.
Thank you. My name is Franklin Chang Diaz, and I'm an astronaut and director of the Advanced Space Propulsion Laboratory. I would like to share with you another possible advanced space propulsion technology that we've been working on for many years. It is called the Variable Specific Impulse Magnetoplasma Rocket, or Vasimir for short. This new engine would allow for much faster space travel than what we can do today. Vasimir is a plasma-based propulsion system. Do you remember the 4 states of matter? They are solid, liquid, gas, and plasma. You can go from one state to the other by adding or subtracting heat from the material. Take water, for example. Its solid state is ice. Add heat and you get liquid. Add more heat and you get gas or vapor. If you add even more heat to the gas, the atoms in it get torn or broken. Remember, each atom is sort of like an egg. It has a central nucleus, the yolk, with positive particles in it called protons, and a blanket, the white, of negative charged particles called electrons in it. When the atom gets torn, these charges are free to roam around every which way. Scrambled eggs. Such a mixture of charged particles is called plasma. Plasmas are very hot, with temperatures of hundreds of thousands to millions of degrees. The sun and the stars are made of plasma. Plasmas are very good conductors of electricity, and they respond very well to electric and magnetic fields. We use these properties to heat them and also to confine them and use their extreme heat to produce awesome rocket propulsion. Electric fields heat the plasma and speed it up. Magnetic fields direct the plasma in the right direction as it is pushed out of the engine. This creates thrust for the spacecraft. Possible fuels for the Vasimir engine could include hydrogen, deuterium, helium, nitrogen, and others. The use of hydrogen as a fuel for the project would also have other benefits. Hydrogen can be found all throughout space. This means we are likely to find plentiful supplies of fuel everywhere we go, and we could refuel the spacecraft for the return trip to Earth. Also, strong magnetic fields and liquid hydrogen make for great radiation shields. This means the hydrogen fuel for the Vasimir engine, as well as the magnet technology we are developing for it, could both also be used to protect the astronaut crew from dangerous radiation exposure during the flight. This is how technology developed for one thing can also be used for another equally important purpose. To heat and accelerate the plasma in deep space flights, Vasimir will use electricity from nuclear power. Vasimir is still years away from transporting humans and cargo to Mars and beyond. Remember the scenario that Jennifer gave you at the beginning of the program. Our team can only take this advanced technology so far, and then it will be up to you. Your generation will make this space propulsion system a reality. Some of you may one day fly on it and become the astronauts that will build the first base on Mars. I've been in space 7 times, but you will be the astronauts who will get a chance to explore the moon, Mars, and beyond. You are the next generation of explorers. So, good luck. Back to you, Jennifer.
My thanks to Dr. Chang Diaz. You know, I can't wait for the day when we receive the first transmission from people on Mars. And maybe you'll be one of them. Well, that wraps up another episode of NASA Connect. We'd like to thank everyone who helped make this program possible. Got a comment, question, or suggestion? Well, email them to connect@larc.nasa.gov. And don't forget to check out this program's Student Challenge. You can find it on the NASA Connect website. So until next time, stay connected to math, science, technology, and NASA. And maybe we'll see you on Mars.